What forces engineers to build vehicles so massive that ordinary roads, support systems, and even logistics assumptions no longer apply? In deserts where surface temperatures soar past 50 degrees Celsius, soft sand saps the strength of every wheel. Abrasive dust shreds air filters in hours, and distances stretch far beyond the reach of conventional fuel tanks. Here, the desert itself is the enemy, breaking lesser machines and pushing survival to extremes. That's why we're counting down the 10 most colossal expedition trucks ever designed for these hostile landscapes, starting with number 10. In 10th place, the Mitsubishi Canter FG649 4x4 sets the baseline for desert expedition trucks. This compact medium-duty platform weighs in at 5,800 kilograms fully loaded, and it relies on a 2-axle, 4-wheel drive layout. To survive the Australian Outback's punishing distances in soft sand, expedition conversions often double its fuel autonomy with dual 300-liter auxiliary tanks, enough to push deep into remote regions without support. Reinforced multi-stage air filtration protects the turbo diesel engine from abrasive dust, while demountable camper modules keep ground pressure low for better sand flotation. The Canter's scale reveals the minimum engineering adaptations needed for desert survival, preparing us for the dramatic leaps in size and capability that follow. Number 9. The M1097A2 Heavy HMMWV stands as a turning point in the evolution of desert expedition trucks, a light tactical platform engineered for the realities of modern desert warfare. Weighing in at a curb weight of 5,900 pounds, the M1097A2 was purpose-built to outlast both the heat and abrasive dust of Southwest Asia. Its positive pressure cab, a direct response to dust infiltration that crippled earlier models, maintains a sealed environment, pushing filtered air through multi-stage intake systems to keep out fine sand. The upgraded radiator and auxiliary cooling fans handle ambient temperatures exceeding 50 degrees Celsius, while modular load beds enable rapid reconfiguration for cargo, weapons, or communications gear. By bridging the gap between commercial trucks and the heavyweight military haulers that follow, the M1097A2 highlights how even smaller vehicles must be fundamentally re-engineered to survive the physics of desert operations, where protection, reliability, and adaptability are as vital as raw size. 8th place introduces the Unicat MD77h MAN TGS 6x6, a purpose-built expedition truck engineered for long-term survival in the world's most punishing deserts. Stretching over 19 feet of wheelbase and powered by a 540 horsepower diesel engine, this platform transforms sheer mechanical scale into human autonomy. The self-contained habitation module, complete with kitchen, sleeping quarters, and sanitation, adds significant weight and complexity, so the design demands a robust triple-axle layout to distribute mass evenly across soft sand. Central tire inflation systems allow drivers to adjust ground pressure while moving, preventing the truck from bogging down in dunes. Extended range fuel tanks and oversized filtration units support weeks of unsupported travel, while the reinforced chassis absorbs the stresses of roadless terrain and the added load of life support systems. The MD77H marks the point where expedition trucks shift from simple transporters to rolling habitats, setting a new threshold for scale driven by the demands of human survival far beyond the reach of conventional support. Number 7. The Beast 6x4 road train truck was engineered for the relentless demands of Australia's interior, where the nearest resupply point may be hundreds of kilometers away, and the sand offers little support for heavy loads. It had a gross vehicle weight rating of 24.5 tons and a tow capacity reaching 70 tons, and this platform pushed the limits of what a 3-axle, 4-driven wheel configuration could accomplish before the era of full 8x8 giants. Its high-ratio gearbox and 30-ton self-recovery winch allowed operators to haul multi-trailer road trains through deep sand and soft track, maintaining autonomy where outside help was impossible. Large integrated fuel bunkers extended operational range far beyond standard haulers, while rugged suspension and reinforced filtration systems were essential for weeks of continuous operation in abrasive dust. The Beast marks the point where desert expedition trucks became not just transporters, but mobile logistics hubs. Its scale was dictated by the physics of sand, the tyranny of distance, and the need to recover itself and its cargo from the most remote corners of the Outback. Number 6, the Unicat IN95H 8x8 marks a decisive leap into the realm of 4-axle all-wheel drive expedition trucks. These machines are engineered for environments where even minor miscalculations in weight or traction can mean the difference between progress and immobilization. The IN95H's full 8x8 drivetrain distributes its substantial mass, over 44 tons at gross vehicle weight, across 16 tires, each with sand-optimized pressure control. Hydropneumatic suspension provides up to 400 millimeters of wheel travel, allowing the truck to maintain constant ground clearance and absorb the irregularities of dunes or rocky outcrops. With locking differentials on every axle and electronically balanced load distribution, the IN95H achieves ground pressure below 1 kilogram per square centimeter, minimizing the risk of bogging down in soft sand. Twin onboard diesel generators deliver autonomous electrical power for scientific modules, air conditioning, and life support systems, enabling weeks of self-sufficiency far from any infrastructure. This platform's scale and redundancy set a new benchmark for expedition logistics, demonstrating how the physics of sand and heat demand not just more power, but smarter, distributed engineering at every level. Number 5, the MAN 8x8 heavy-duty military platform sets a new standard for desert logistics with its 20-liter V8 engine delivering 730 horsepower and more than 3,000 Newton-meters of torque. This powertrain is not about excess. It is a direct response to the demands of hauling armored payloads and critical supplies across vast roadless expanses where soft sand and extreme heat quickly overwhelm lesser machines. The multi-stage air filtration system operates in layers, stripping abrasive dust from intake air to protect engine internals during weeks of continuous operation. Hydropneumatic suspension adapts in real time, maintaining stability and traction as axle loads shift over uneven dunes or rocky outcrops. A radiator package enlarged by 30% ensures reliable cooling even as ambient temperatures soar past 50 degrees Celsius. The MAN 8x8's 4-axle, all-wheel drive architecture distributes immense weight across 16 tires, minimizing ground pressure and preventing bogging in sand. This platform bridges the gap between expedition vehicles and the specialized tractor-trailer systems that follow, demonstrating how military-scale engineering becomes indispensable when the mission demands both payload and survivability in the world's harshest deserts. Number 4, the Oshkosh M174 heavy equipment transporter redefines how military forces move armored payloads across unforgiving desert terrain. At the heart of this system is a 15.2-liter Caterpillar C15 engine, producing 600 horsepower, delivering the torque needed to pull massive loads through deep sand and over rough ground. What sets the M1074 apart is its integrated load handling system, allowing it to self-load and unload tanks or armored vehicles, eliminating the need for external cranes and reducing exposure in hostile environments. The transporter's modular trailer spreads up to 60 tons of payload across more than 40 wheels, keeping ground pressure low enough to prevent bogging on soft surfaces. Redundant cooling fans and reinforced filtration systems ensure continued operation in temperatures exceeding 50 degrees Celsius and in abrasive dust storms. This tractor-trailer synergy marks a pivotal transition from rigid 8x8 platforms to purpose-built systems designed for rapid, autonomous deployment of heavy armor, directly addressing the logistical realities of modern desert warfare. Number 3. The AT422T and MT250 crane transporters embody the shift from mere heavy haulage to mobile construction platforms designed for the heart of the desert. Measuring up to 500 inches in length and weighing nearly 70,000 pounds at curb weight, these multi-axle giants combine the brute force of a 25-ton hydraulic crane with the mobility required to traverse soft sand and uneven terrain. Hydraulic outriggers deploy at each corner, anchoring the vehicle and stabilizing massive lifts even when ground conditions are unpredictable. Unlike pure transporters, the AT422T and MT250 can erect bridges, recovery ramps, or critical infrastructure modules without relying on established roads or external cranes, solving the problem of building and repairing lifelines in the middle of nowhere. Separate hydraulic oil coolers and reinforced filtration systems keep the crane systems functional under relentless heat and dust, while the multi-axle chassis distributes immense loads to prevent the truck from sinking into the sand. This dual-role capability, lifting and moving, marks a decisive escalation in both scale and function, pushing the concept of a desert expedition truck into the realm of a self-contained construction site on wheels. Number 2. The Oshkosh M1070 heavy equipment transporter stands at the pinnacle of active military desert haulers, designed to move 70-ton armored vehicles across terrain where ordinary trucks would bog down or overheat. The M1070's scale is a direct response to the physics of sand and heat. Its 10x10 drivetrain, 5 axles all driven, spreads the immense weight of a main battle tank, keeping ground pressure below 0.9 kilograms per square centimeter. This is critical for preventing catastrophic sinkage in soft dunes. Under the hood, a 19-liter Cummins diesel engine delivers 700 horsepower and 3,150 newton-meters of torque, channeled through low-range gearing and full locking differentials to maximize traction in loose sand. Dual 947-liter fuel tanks grant an operational range of 800 kilometers, essential for missions far beyond supply lines. Oversized radiators and reinforced multi-stage filtration systems keep the engine alive in temperatures above 50 degrees Celsius and in dust thick enough to destroy lesser machines. The M1070's sheer size and engineering focus mark the high point of military expedition trucks, built not for spectacle, but to solve the brutal logistical challenge of moving armored payloads through the world's harshest deserts. And finally, in first place, the Berliet T100 stands as the largest verified off-road desert transport truck ever constructed, a machine whose sheer scale was dictated by the unforgiving realities of the Sahara. Stretching nearly 50 feet in length and 16 feet high and 16 feet wide, the T100 was engineered in the late 1950s in France for a singular mission: hauling entire oil drilling rigs, bulldozers, and modular infrastructure across dunes where no road existed and no conventional hauler could survive. Its 12-wheel, multi-axle layout distributed more than 100 tons of payload over a vast footprint, keeping ground pressure low enough to float on loose sand that would swallow lesser vehicles. At its heart, a 600-horsepower Cummins fifth 12 engine drew from a 370-gallon fuel tank, an autonomy requirement set by the vast roadless distances between Saharan oil fields. To outlast abrasive dust, the T100 relied on multi-stage cyclone filtration and oversized radiators, while its heavy-duty suspension and locking differentials absorbed the relentless stresses of dune crossings. Only 4 units were ever built, each serving as a mobile platform for industrial ambition in a landscape that defeated ordinary logistics. The T100's unmatched dimensions and payload were not excess. They were the minimum viable answer to the physics of sand, heat, and distance at the dawn of the Sahara oil era. In the end, these megatrucks reveal that scale in desert engineering is never about spectacle, but about solving problems where geography itself becomes the ultimate obstacle. For more deep dives into the world's most extreme machines and hidden infrastructure, subscribe to our channel. Across all 10 megatrucks, one pattern stands out. Sheer scale is the only answer when desert physics defeat ordinary machines. Every axle, gear, and suspension is engineered to push back against hostile terrain, not for spectacle, but for survival. Extreme environments demand solutions. Subscribe for more deep dives into engineering on the edge.